Hello, Professor. This is my presentation for topic 6, DQ1. I share my screen to explain my assignment. Okay. First, I begin with the assumptions that underlie the hypothesis testing for paired data, multiple population means, and variance comparisons. For paired data, observations are assumed to be independent of each other. And the next assumption is that it's normality, where the differences between the pairs should be approximately normally distributed. The potential consequences for violating these assumptions and the remedies would be violation of independence is the standard errors might be underestimated, leading to overly optimistic p-values. The remedy would be to ensure that the paired observations are collected independently and avoid using data with innate dependencies. The paired t-test may be appropriate when the same item or group is tested twice. For example, this test is appropriate for the before and after effect of a pharmaceutical treatment on the same group of people. The reason the paired test should be appropriate occurs when the data points are not independent and each data point in one sample can be matched or paired with the specific data point of the other sample. The practical limitation would be for the paired data involves observations that are not independent, and outliers could have a significant effect on the results, specifically in small samples. Now, for the multiple population means, the assumption of independence refers to the observation within each group being independent of each other, as well as group themselves should be independent. The other assumption is normality, referring to the data within each group should be normally distributed. For the assumption of homogeneity of variances, refer to the variances of the different group ought to be equal. And violation, the consequences would be for the violation of independence is that the non-independent observations might lead to increased type 1 error rates. And the remedy would be to make sure these are independence, they're independence within and between groups. Examples for multiple population may be appropriate when comparing the average scores of students from 3 different teaching methods like X, Y, and Z to establish if there's a substantial difference in academic performance. The reason is that the ANOVA for multiple population means is appropriate when using more than 2 groups to compare. Some limitations for multiple population mean would be multiple testing when conducting multiple comparisons. The probability of making a type 1 error increases. Now, for the variance comparison, the assumption of normality is essential when the population from which the samples are drawn should be approximately normally distributed. The next assumption is homogeneity of variances, referring to the variances of the population being compared should be nearly equal. The potential consequences for variance comparison for the violation of normality is normal data might affect the accuracy of confidence intervals and hypothesis testing. The remedy would be to perform the data or to transform the data or to employ a non-parametric test such as the Mann-Whitney U-test. Examples of situations would be the variance comparisons may be appropriate when comparing the variability in the production output of 3 diverse manufacturing procedures to determine if one process has significantly higher variability than the rest. This is essential to ensure that the variability in the data is consistent across groups. If the variances are significantly different, it could affect the validity. And some practical limitations for variance comparison would be that many statistical tests assume homogeneity of variances across groups, and violation of this assumption could affect the validity of the results. Now, I look at the last part of this question, which is how can Python be used to develop a useful tool in this context for paired data as well as for the other two, which are multiple population means and variance comparison. Python could be used by importing the libraries such as pandas for data manipulation and SciPy for statistical analysis. Then the next step will be to load the data set or to create a sample using pandas, followed by performing the paired t-test or the multiple population means or the various comparison analysis. And here is for the paired sample. I did some data here that I use, which is like a sample data set here that I use. And this, I use some random numbers here. And I follow through with the steps to perform the t-test, and these are the results. For the multiple population means, I imported the libraries, load the data set, or in this case, I created sample data sets. And I use the ANOVA test. And this is how I did it. I created 3 groups with these sample data here after I imported these libraries. Then I did the ANOVA test, and I have the results here. Now for the variance comparison, it is similar, where I imported the libraries, loaded the data set, or in this case, I created a sample data set using pandas. Then I did the Levine test, and these are the results here. Or it could also be done by visualization, where I did a box plot here. Now that is my presentation for topic 6, DQ1. Thank you.